Ja, hej och välkommen till en pass till för geoteknik. Det här passet gäller om Geosuite på IFC 4.4 projekt. Det är en BuildingSMART projekt. Jag heter Artemis och är inblandad i detta projekt. En liten påminnelse angående frågor. Ni kan gärna använda Q&A för att ställa frågor. Självklart, ni kan kommunicera även med chatten med andra deltagare. Och vi ska försöka att svara alla frågor i slutet av passet. Så jag heter Artemis, jag är Geotechnical Software Solution Engineer och jobbar på Trimble som geoteknisk sakkunnig eftersom tidigare jobbade jag även i branschen. Och idag så agenda ska bli som ni ser här. Och eftersom projektet är internationellt tror jag det är bättre om vi tar det på engelska så att ni har en bättre upplevelse och förståelse av projektens ämne och historik. So we are going through a little bit on the background and innovation of this IFC project. Then what are our current activities? The main focus, then a topic that is so-called focal points, all the uncertainties that we have been through in this project and why we are doing that. And last, what is the current status and the sprints. So I'm going to present some slides from the previous year and end up where we are now. So I'm going to describe actually what we have in mind for this schema for the IFC tunneling project and how this fits in Geosuite. First of all, it is an ongoing project as of 2022. Right now, for this year, we are, let's say, in this final stage. It has got some extension. We had the kickoff for our group Geosuite in the beginning of 2023. And we will see if we will get any further extension next year, depending on the topics that they will be implemented. So we from the geology and the geotechnic side, we fit to the project to the rock mechanics. And we are closely connected to the engineers who are doing the numerical analysis, which are the good material models to go for and how we can describe, for example, our rock mass in the best way. For example, is it continuous? Is it discontinuous? Which parameters do we need, and so on. So there is where Geosuite fits place. We do not do the calculations, but we fit in and we understand and we know what these engineers are up to and give feedback to them. So it's a traditional way to collaborate among the geotechnicians. So a little bit on the background and motivation, why we are doing this. It is actually because tunneling requires description of the ground conditions, and there are typical challenges in large infrastructure projects where someone has to answer some topics such as how we are working in large volumes with geotechnical and geological factual data. Then the translation into simplified but representative geotechnical models. Then verification and update based on additional data that might come in the project. Of course, the high construction costs and with the relevant ground conditions is a major factor of uncertainty that we need to get answers for. And then it's the long-term storage and access that is required for operation and maintenance of a tunnel. So why we are doing this again to continue? There are some current activities that are going on, and here is where we have got input and the IFC project from various actors, such as the German DAUB or the French Mine, OGC and ITES, and other groups of international association of, for example, engineering, geology, and so on and so on. But we do need feedback to have some case descriptions. We do need feedback for the taxonomy of the conceptual model. We do need also various concepts to describe the different types of uncertainties, and then get input, of course, in various geometrical representations, as well as have a concept to link this model of ground conditions to our design. And previously, there was an older version of the IFC SIMA, so-called 4.3. In the earlier version, there was nothing about ground or soil. There were roads, there were rails and ports and harbors, and from ports and harbors came a proposal also for ground units. So from about the ground material, and this was published a couple of years ago. And now we are on the process of this becoming the official standard for the IFC. So this IFC 4.3 covers some topics of describing the geological structures, such as strata and layers, but this was very simplistic. It does not distinguish the units, nor includes geotechnical properties and parameters, and of course, what is their purpose. And for geotechnical tunneling models, we need so much more. And this was actually our starting point for the 4.4. So there are a lot working groups, and among these is the group that we are involved with Geosuite, and we meet every week. And as a part of this OGC group, we combine feedback from all other groups, and then we make it available to others. And here is where our work actually starts. In this IFC project, the first task was to create the so-called requirement analysis and to define use cases for ground models that could be supported by the IFC. The description can be found in the BuildingSMART documentation, and it regards geological factual data, those that are the data that are being collected and then exchanged from modeling for early project stages. Then it can be, for example, specific requirements for design, specific needs during the part of construction and maintenance. And actually, this is the one that is most important for us, because it includes topics such as phase logs and small-scale models with structures. And then we also have the spatial requirements for models for tenders and prognoses and geological documentation. And of course, all these overlap, especially in the beginning, before we start putting the things into chapters. So what is the main focus? We need to cover factual data, because when we do the prognosis model, we need to distinguish what has been observed and what was our interpretation. So we need to cover any kind of observations, boreholes, and so on, as well as the documentation in the field. Then we need to develop geological models that describe the whole story and then break it down to models for several purposes. For example, slope design and tunnel design. And then we need to link these models somehow to, say, for example, if it is a smart model, and if it takes into account the ground conditions, and it would be good to link these kind of models somehow for get our design. And this is our approach. How do we work? So let's call it this one, the book A. The book A includes observations and factual data. One part of the model will describe all these observations from maps and the discontinuities, the discontinuous data, the test, the borehole, the geophysics. And from these, we will create book B. That is our interpreted models, which is with hot zones, with geological and geotechnical units. And from these, we derive the description of the expected conditions in my alignment in the tunnel. So I have, for example, this model, and it tells me that if this part of the tunnel is in this unit, and if there is a discontinuity, and if it will change, and so on and so on. So a step from factual data to an overall interpretation to design related interpretation. And this design related thing is kind of an output. So where we have described the design related groundwater conditions, contaminations, discontinuities, whatever, and then the tunnel design can be attached to it. So then we can say that, for example, for this part of the tunnel, we will use this excavation method, and we will need this kind of injections with that pattern. And we can also link it to other kind of topics such as health and safety, logistics, whatever. So that is, for example, the design is linked with support types. We expect a groundwater type A, and for example, B in another place, and then what kind of support types we will need. So 1, 2, and 3. And if we do have a good and updated prognosis model, then I can easily update my current one. So it's the so-called design solution model. And then it comes to construction, to execution, and we will be somewhere here. We will be reporting discontinuities, fault zones, and presenting traditional reports. Have groundwater flows, have phase logs in digital formats, and all these will fit in my model, and I get a prediction. So whatever I enter in my model during tunneling, documentation, excavation, it would end up here in the columns in the part of the island, and then compare it with the prognosis that we have before. Of course, the design follows where we have certain support types. And we can say that we have used as applied, for example, design solution in every support type respectively. And of course, these should fit with the encounter geology. So for Geosuite is mostly on the input side, the so-called book A and book B. And we do use this classification of factual data being book A, interpretations being book B, and design being book C. And here are the two main description characteristics. So what is it included in the book A? And the same applies for book B. And we need a clear definition what is what, including semantics, and deal with uncertainties regarding geometry's complexity for the conditions that we have. And we also have the synthesis model that we talked before, and we need to link it to the design. And then we come to the conceptual model, which was developed by the tech team. It's the technical guys that are writing it into their languages. And they really come up with an output in the schema. So here we do have various kinds of containers that contain information like interpreted object, special geotechnical interpretation elements. And in book A, we do have everything inside that can be linked to something. And as you can see here, different colors do represent different groups, so different kind of containers. And I think it would be easier if we have various kind of examples. So all the things that are defined in the schema are shown in the next slides as an overview. And also you can find further information in the BuildingSMART documentation, which is on the BuildingSMART website. I can send you the link later in the comments. So here you can see various kinds of examples that are included in the schema. The various kind of containers. So if we, for example, have a tunnel face as a container, this will include two mapped zones that include further kind of information, such as water inflows or discontinuities, and whatever my software can carry. And of course, as any project, we do have some uncertainties that we need to get answers for, and these are the ones that we have met so far. And we currently, the ongoing concerns are the listing types and sources and the definitions of, for example, the types, the geometrical uncertainties, and the geometrical resolution that we will have. Here is the concept that it's so-called voxel representations, and the voxels represented are required for modeling our spatial variations of the soil and rock properties. And the status right now is there are 3-week sprints. We are at the end of the project, so the current sprint is sprint 3, and it includes various topics. And sprint was the most interesting for Geosuite and geotechnics because it includes the observation and the interpretations. We have gotten extensions for doing checks and corrections, and perhaps we can continue later with even excavation and wrap up the project. Before it was mainly alignments and other kind of topics related to quadri that were on the first sprints. And here you can see an overview of the project over the last year. And here it's the link that I promised you where you can find the documentation for this project. So I think that we got this, and thank you so much. So if you have any questions or if you have some feedback for this kind of project, please contact me or at support at trimble.com.